Okay, in this video I'll show you another method to do integration by parts, and it's called the DI method. So I first learned this method from blackpenredpen, and it's so nice because it's so easy that it's all well organized into a table. So I'll show you this method. This is the standard way to do integration by parts, and basically you have two functions, the product of two functions. And to compute this integral, you use this formula, and this formula comes from the integrating the product rule for derivatives, so nothing that crazy. So how does the DI method work? So we have to construct a table, and we put D and I. D stands for differentiating, and I for integrating, and we have to put a plus or minus sign. As you can see, it resembles this plus and this minus sign. You'll see why in a second. So we have to differentiate a function, and in this example, as you can see, we're integrating f prime, and it becomes f, and we're differentiating g, that becomes g prime. So what we have to do is to put here the function that we have to differentiate. So I'm going to write down g, and we integrate in f prime. Of course, if we differentiate g, we get g prime. If we integrate f prime, we get f. And now how can we express the result? We have this nice table, but we don't know what to do with it. So we basically have to multiply the diagonal element. So this equals to f times g, and then we have to add with a minus sign the integral of the product. So basically when we multiply things on the same row, we have to put an integral. When we multiply alongside the diagonal element, we don't need the integral. So as you can see, f times g minus the integral of f times g prime. So this is how the table works. Now I'm going to show you a simple example, and you can also do multiple integration by parts with this method, and here is where the power of the DI method really helps you solve integrals. So I'm going to probably write down this integral. Okay, the integral of x squared e to the x. This is very simple. We differentiate x squared and we integrate e to the x. We differentiate x squared and we get 2x. We integrate e to the x, and it's always e to the x. Now we can stop. We can multiply e to the x times x squared minus the integral of e to the x times 2x. But we can apply integration by parts twice using the same table. This is why it's so comfortable. We differentiate 2x and we get 2. 2 is the answer. And we integrate e to the x, and it's always e to the x. But what if we differentiate and do integration by parts basically 3 times? We differentiate 2. We have to put a minus sign because here there's a plus, minus, and minus sign. And we get 0. The integral of e to the x is always e to the x. Now we have to write the answer to this integral. So we have to multiply the diagonal elements and add all of them, of course. So let's do it here. E to the x, and as you can see, there's a common factor of e to the x, so we can pull it out of the sum. So we have e to the x that multiplies x squared minus 2x plus 2, and then we have minus the integral of 0 times e to the x, but 0 times e to the x is the integral of 0, and the integral of 0, it's a constant, so we can just use the constant, add the constant to the other constant, and get an overall constant that we call c. C is the overall constant, and here's the answer. And if you differentiate this function, you get x squared times e to the x back. So this is a very interesting thing to do, and once you start using the DI method, there's no way you get back to the usual formula, even though this table is built on this formula here. So it's very important that you understand the basics behind integration by parts.